Welcome students. In earlier sessions we have seen what is a CPU scheduling algorithm, criteria for CPU scheduling, non-preemptive and preemptive scheduling algorithms, and device queues, waiting queue, and very many kind of queues available for scheduling. Here in this video I will explain first come first served scheduling algorithm. It is the easiest one, and first in first out, also known as first come first served, is the simplest scheduling algorithm. First in first out simply queues processes in the order that they arrive in the ready queue. In this, the processes that comes first will be executed first, and the next process starts only after the previous gets fully executed. So this is a non-preemptive scheduling algorithm because the processes executed only previous processes gets fully executed. Here we have an example to demonstrate the first come first served algorithm. This is how the questions will be given in exams: processes, number of processes, and their burst time. Here duration means the execution time of each processes and the order of the processes, the arrival of each processes. Here arrival time is assumes all the processes arrived at 0th second, and the order is given. So process 1 is arrived first, process 2 is arrived second, process 3 arrived at third. Here, in order to find the waiting time of each processes, we have to build a Gantt chart. This is a Gantt chart, just a diagram to help to find out the average waiting time here. Now here we start at 0th second, we assume at 0th second, and process 1 comes first, it execute for 24 nanosecond. Okay, and then process 2 comes and it will run for 3 nanoseconds. So 24 plus 3, 27. And then process 3 starts its execution, 27 plus 4, 31. Now this is a Gantt chart. Now we have to find the waiting time of each process. Here process 1's waiting time, so here arrival time is 0. Process 1 starts its execution at 0th second, so 0 minus 0, 0. And then P2's waiting time is 24. Here P2 starts its execution after the completion of P1. So P1 will run after P1 executed, and it will run then its waiting time is 24. And then P3 executes after P1 and P2. So P1 plus P2 is 27. So this is the waiting time of P1, P2 and P3. Now we have to find the average waiting time here. Average waiting time can be found by sum up all the processes waiting time divided by number of processes. Here 0 for P1, 24 for P2, 27 for P3 divided by total number of process 3 will give you 51 divided by 3 will give you 17. Okay. Now this is how we have to find the average waiting time for first come first served algorithm. Now we have a question here. There are 5 processes P0, P1, P2, P3, P4, and each processes burst time, execution time is given, and also the arrival of the process is also given. Now we have to find the average waiting time for this question. Now we have to build the Gantt chart first. Now building the Gantt chart. Okay. So we start at 0th second. We start at 0th second. Assume that no processes here, and P0 starts executing. It is the first process to enter the queue. So P0 starts executing, and it will run for 2 nanoseconds. Okay. And then P1, next process, P1 starts executing, and it will run for 6 nanoseconds. 6 plus 2, 8. And then P2 starts its execution, and it will run for 4 nanoseconds. 8 plus 4, 12. And then P3 starts its execution, and it will run for 9 nanoseconds. 9 plus 12, 21. And then P4, the final process, will start execution, and it will run for 12 nanoseconds. So 21 plus 12, 33. Now we have to find, this is the Gantt chart for the given question. Now we have to find the waiting time of each process. Now process 0, this is the shortcut here. process 0 starts its execution at 0th second. So 0 minus arrival time 0. Okay. Okay. And then P1 starts its execution as 2 nanoseconds. So 2 minus arrival time 1 will give you 1. Okay. And then P2 starts its execution at 8th nanosecond, and arrival time of process 2 is 2. So 8 minus 2 6. And then P3 starting time is 12 minus arrival time 3. 12 minus 3 9. And then process 4 starts its execution at 21st nanosecond. 21 minus arrival time 6 will give you 15. Now this is the waiting time of each processor. Now we have to sum all this, it will give you 31. So sum of all of the processor waiting time is 31. So 31 divided by number of processors 5. Now it will give you 6.2. This is the correct answer to this question. Yes, this is the correct answer. So in next video we will see shortest job first algorithm and remaining shortest job first algorithm. Until then, thank you.